Hello viewers, my name is Damilari. In this lesson, we'll be looking at the topic electrolysis. To start with, what's the meaning of the word electro? It has to do with electricity. Then lysis means splitting. Meaning, if we say electrolysis, we are talking about how electricity will split an electrolyte. And when we say electrolyte, we are referring to a compound that is either in a molten state or solution. An example of this electrolyte is an acid, especially the inorganic acid. These are strong electrolytes like HCl, H2SO4, HNO3. They are strong electrolytes, unlike the weak electrolyte, which is organic acid. So organic acid is actually weak electrolyte. Base is also an electrolyte, like NaOH, a strong electrolyte. Salt is also an electrolyte, like sodium chloride. And why do we call them electrolytes? That means electricity can split them into ions, so they are electrolytes. Now there are some terms we'll be looking at as we consider this topic, electrolysis. The first one is cell. Once you hear cell, that's the source of electricity. And another one is electrode. Electrode is the passage of electricity. Then anode, from the letter N. N is for enter. Enter, that means where the current will enter. The electricity that is coming to split the electrolyte must follow a particular pathway, and that is the anode. So anode is where current enters, at the same time electron leaves, meaning that once the current enters the anode, it will push out electron, and that's the basis of conductivity of an electrode, especially metals. Then most of the anodes, or most substances that they normally use for anode, we have carbon, graphite, platinum. You can say CGP, the one they use in university, cumulative grade point. Use it to remember that anode, they can use carbon, graphite, platinum, etc. to make anode. They are majorly like rods. So like rods through which current can enter. And remember we said at anode electron leaves, and that's what we call oxidation. According to redox, loss of electron is oxidation. Now cathode, you can use letter T to remember out, 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 meaning that this is where current leaves. That means where it will go out. So at this cathode, electron will now enter. Once current is leaving, the electron that was forced out, so it means there will be a return of electron. So, and that's why we call that reduction, because the gain of electron is actually reduction. And some substances that can be used for cathode includes mercury, platinum, iron, copper, etc. So there are a lot of things we can use once they can conduct electricity, so they can use them as a cathode for current to pass. Take note, there's another term we call ionization. We got this from ionic theory. According to this scientist called Arrhenius, he stated that compound in solution or in molten states, that they can split into ions. That means the cation, positive ion, and then they can also split to anion, the negative ion. And once they split, he said this will be moving randomly. That means the ions, the plus, the minus, they'll be moving randomly. Unlike electrolysis, which involve electricity, the electricity will actually arrange the ions that have been splitted. So electrolysis will arrange. So it means it will make the cations go to the cathode, anions to the anode. So that's for electrolysis. But if it is ionization, they will be moving randomly. Now let's still proceed. From electrolysis, we have said they will use electricity to split the electrolyte, and they will arrange. So like I said, it will not be moving random. They will arrange the ions such that cations will move to the cathode, anions will move to the anode. Another term we use in electrolysis is what we call electrolytic cell. This is a container. As you can see, the container of what? Of the electrolyte we want to split. Remember we said electricity will split electrolyte, so it means that electrolyte we want to split. So the container of it is called electrolytic cell. So these are the electrolytes, like sodium hydroxide, like copper sulfate, like hydrogen sulfate, like sodium chloride. They are different electrolytes inside this container called electrolytic cell. Also, we have anode and cathode. That means our electrodes, they are inside the same container. So this anode and cathode are now connected to an electric source. That means the battery. So this is the positive and the negative representing battery or cell. And take note of the drawing. This drawing is saying that something is coming out of the anode, and that is electron, and that's why you see E at the top here. So it means electron is going out at the anode, and that's oxidation. And take note, where this electron is going out, that means anode, we call it positive. So it means anode, that is the positive electrode. But when we get to electrochemical cell, reverse will be the case. The anode will become negative. But here in electrolytic cell, it is positive. So electron goes out of the anode but enters through the cathode. And this is where reduction takes place, because there is a gain of electron. So this is just the electrolytic cell, which contains the electrodes and the electrolytes. So another point we'll be considering is looking at specified electrolyte. That means we want to start the real work, the electrolysis. So we have to specify an electrolyte we are going to use for our electrolysis. And we'll also be considering some factors that will determine preferential discharge. Why? Because we'll be noticing two cations, two anions. So meaning that there will be a competition between two cations, there will be a competition between two anions. So meaning we have to give preference to one out of the two ions. So, and that's why we consider preferential discharge as we are looking at a specified electrolyte. So the first electrolyte we are looking at is acidified water. From the word acidified, it means it has to do with acid. Then the water means that they have diluted the acid. So meaning that acidified water is the same thing as dilute acid, and that acid is H2SO4. So this is the electrolytes we are using specifically. And take note, there must be an anode and there must be a cathode where electricity will be passing. And this is made of platinum. So platinum are the electrodes we'll be using for our acidified water. There is a particular drawing for this. They call it Hoffman voltameter. So this Hoffman voltameter shows us how there will be a movement of some gases. That's talking about oxygen gas, which is just one molecule. Then hydrogen gas, which will be two molecules. So at the end of this electrolysis, you get to know which one is one, or how do we get one, because from the drawing you notice that this will be covered to somewhere here, but this one will be covered to somewhere here, meaning this small space here is the gas, oxygen, just one molecule, but this bigger one is the gas for hydrogen, that means double. So, and then in the middle here, that's where the electrolyte will be poured. So the electrolyte will be poured through this particular funnel here. So we pour your H2SO4, which is diluted, through this, and once it gets here, there is a platinum here. So both are the anode and the cathode, so which is connected to electricity. So once it is connected, the current will start flowing, and then the electrolyte will start splitting into cation and anion, and at the end you will see oxygen and hydrogen gas being formed. So let's just analyze it here. This is our H2SO4, this is our H2O. So the cations we can get from H2SO4 is H, that's hydrogen ion. Likewise in water, hydrogen ion is under cation there. But for anions, the SO4 is the anion we'll be seeing from here. The anion is hydroxyl ion. Now, as you can see, we have two cations, two anions, so there must be a preferential discharge. That means which of the two will be discharged. So let's start with cathode. Remember, any cations have to move to the cathode. That means the cations from this solution will move to the cathode, that's to the right hand side here. Then the anion will move to the anode. So meaning that at the cathode, what will happen? Take note of this, that anywhere you see platinum, hydrogen has affinity for platinum, meaning that the platinum which is here will drag hydrogen to itself. And remember, the cations, they are hydrogen, hydrogen. So mean that this platinum has the ability of dragging hydrogen to itself, which will be adsorbed. When I say adsorbed, that's the ADS, not AB, but adsorbed. That is bringing it to the surface. It will drag the hydrogen to the surface. So that's one of the factors that will determine preferential discharge. Talking about nature of matter. So meaning that the nature, it could be that it has something that has affinity for the ions. So let's proceed. So take note of that affinity. So I will still mention that later. So now at the cathode, hydrogen will be preferentially discharged. Why? Because we have hydrogen on the left, hydrogen on the right. So they are both hydrogen. So they don't have choice. It's hydrogen that will be preferentially discharged. And since they are coming to the cathode, at the cathode there is always a gain of electron, and that's why you see plus E minus, so a gain. And once electron is gained, that's what we call reduction. So and that's why reduction takes place at the cathode. So this hydrogen, that electron has been added to it, so it means it will turn to H. That means immediately it gains electron, it becomes neutral. And H cannot stand alone, it's a diatomic gas, and that's why the H will still react with another H to give us the hydrogen gas. So that tells us that this hydrogen gas is what will come out of the cathode, and that's why you can see it here. Hydrogen gas is coming out from this cathode. So cathode is where this platinum is. So at the cathode we have hydrogen gas, but take note, it will be 2 molecules. So I will say give you the confirmation of that. Now let's go to the anode, where we have both SO4 and hydroxyl. So here now we have to think of which of the two will be preferentially discharged. Here I wrote OH, that it will be preferentially discharged. Why? Just come and check what we call increasing electronegativity. That means each of them has a particular position, and that's why you can see some of the factors that will determine preferential discharge is position. So anyone that is lower, take note that that lower is the one that will be discharged, just like a police and a soldier. So in a car, so the police, we have to stand up for the soldier. So that's why the one that is lower will be preferentially discharged. You can see OH is lower than SO4 because it is increasing like this. So OH will be preferentially discharged, and that's why you can see that OH is selected here. But here we said there is a loss of electron, that's why you see minus, unlike at the cathode that there is a gain. So this loss of electron will make the hydroxyl ion become neutral OH, and the neutral OH will still add to another OH, because this reaction, there are a lot of it coming. That means a lot of hydroxyl. So the hydroxyl will react with another hydroxyl and turn to water and oxygen, but this oxygen cannot stand alone, and that's why it will react with another oxygen and form oxygen gas. So the conclusion here is that oxygen gas will come out through the anode as hydrogen comes out through cathode. So the oxygen gas, you can see it from here, that is coming out from the anode. So the anode is this left side. So the oxygen gas, take note, is 1 molecule. For hydrogen it is 2 molecules. So how do I know that it is 1 molecule and 2 molecules? You can just take a chemical reaction of water, where we have H2 then plus O2. So what will this give us? We know hydrogen and oxygen will give us H2O. So from that H2O, you can balance your equation by saying that there is 2H here, 2H here, 2O here, but here is 1. So add extra 2, meaning that 2O is here, then the O here is also 2, but the H has become 4, so you put 2 here. That shows that hydrogen is 2, oxygen is 1. Now the conclusion of all we have done in this electrolysis of acidified water is that due to the oxygen and the hydrogen that is produced, then it shows that we have water being lost, because oxygen and hydrogen will give us water. So meaning that water is lost, and that will make the acid become concentrated, meaning that the acid that was diluted full of water before, so it has lost most of the water, so the acid will become concentrated. Now let's move to other factors. We have mentioned position, like when we said hydroxyl will be preferentially discharged over SO4. We will still later look at concentration as a factor. We have looked at nature, that means in terms of affinity, where we saw platinum that it has affinity for hydrogen. So we'll still look at where mercury we have affinity for sodium. So let's proceed. Then in under this nature where we looked at affinity, nature can also be based on similarity. That means if copper is your electrode, then copper can be discharged. So we are coming back to that, and the way this one will take place for copper to be used as your electrode and then copper sulfate also as electrolyte, it means that copper you expect dissolving. The copper will be dissolving, especially if you are dealing with impure copper and pure copper. That's in the purification of copper. So there's an electrolysis that is used for purification of copper, such that any impure copper, so that one can be on the left, that's the anode, then pure copper on the right, that's the cathode. So in this situation, the impure copper here, it will dissolve into the copper sulfate. Once it dissolves into copper sulfate, it becomes pure, and that pure will come and cover this pure and make this copper become bigger. So meaning when you have copper as your electrode and the electrolyte is also copper electrolyte like copper sulfate, it means automatically it's copper that will be discharged from here. So that's what the similarity is talking about. So that's for nature. So it's remaining concentration, which I am yet to use for my explanation. Now let's move to another specific electrolyte. So here we'll be using CuSO4 copper sulfate solution, meaning that CuSO4 and water. So the electrode here is also platinum and platinum. So let's take our CuSO4 and the water. So the cations here, that's Cu2 plus, for this one H plus. The anions, the remaining thing, SO4, then OH. So that's the anion. Now what of preferential discharge? That means between copper and hydrogen, which one will be preferentially discharged? So here I said copper will be preferentially discharged. Why? Because of the position, meaning that copper is lower than hydrogen. How do we know? So you can just check this drawing that shows us the increasing electropositivity. So as we can see, copper is here. It is lower in the electrochemical series, or you call it activity series. So copper is lower than hydrogen in the activity series or electropositivity arrangement. So take note, there's something we call active series. In the active series, you will not see all this plus plus plus. It will just be HCU. That's active series. But once you say activity series, you will see plus and the likes. So as we said earlier, that the lower one, copper, will be discharged because it is below hydrogen. So here now, meaning that it's copper that will be preferentially discharged. And where will copper be discharged? That's at the cathode, because copper is cation. So cat and cat, cations going to the cathode. And what normally happens at the cathode, there's always a gain of electrons. So the gain means plus. So it returns to neutral copper. So then at the anode, we have OH and we have SO4. Which one will be preferentially discharged? So we said OH will be preferentially discharged. Why? When we still come and check our activity series for OH, so we can see that OH here is actually lower than SO4. So SO4 is above, OH is below. So meaning that OH will be preferentially discharged and is going to the anode, because it's anion going to anode, an. So and at the anode, there's always a loss of electron. So when electron is lost, it becomes neutral OH. Then looking at this OH, the OH won't stand alone. Like there will be a kind of repetition. So they will come together to give us water and oxygen. Likewise, oxygen can't stand alone. It must be in a duplicate. That means diatomic, and that's why it forms oxygen gas. So what is our conclusion here? The conclusion is that the compound will become acidic. Why? Because we said hydrogen and SO4 will be left. And what is hydrogen and SO4? That's acid. H2SO4, they will be left. While copper and the oxygen gas are being removed. So when copper is removed, oxygen is removed, it means it will remain hydrogen and sulfate, so which is an acid. Then if you notice that the color of copper is actually blue. So if the color of copper is blue, meaning as copper is leaving, then the blue will begin to fade away. So that is for the copper sulfate. So another one that we can use for our electrolytes or specified electrolyte is still that same CuSO4, but now we want to use our anode as impure copper and our cathode as pure copper, just as I said earlier. So in this situation, that's for the nature of electrode. When you have this kind of nature, that means copper copper, so which one will be preferentially discharged? So let's start with our CuSO4 and water. The anion is SO4 here, the anion is OH here, but the cation is Cu, cation is H plus. So which one will be preferentially discharged? So at the anode between OH and SO4, do you know that none of them will even be discharged? Why is it that neither SO4 nor hydroxyl is discharged? The reason is because copper has a tendency of dissolving. Why? Because the copper is inside copper sulfate, so it can easily dissolve faster, and that's why it is copper that will be discharged. So we don't need SO4 and OH here. And again, looking at the standard electrode potential of copper is higher than all this SO4 and OH. So the standard electrode potential of copper is higher than all this SO4 and OH. And when we talk of the standard electrode potential, that means looking at all these ions, we related them with hydrogen. So and that's why for copper, its own is actually higher. Why? Than all the hydrogen and the likes, because most of the ones that are from the top, they are negative, that's from their standard electrode potential, they are negative till you get to hydrogen. So but others will it will become positive, so meaning that copper its own has higher standard electrode potential, so it can easily dissolve. So that is for the electropositivity. So the next one is which one will also be preferentially discharged. We have seen the one that is preferentially discharged at the anode, that it is carbon, because it will dissolve. Now since it has dissolved, what will now happen? Remember, the copper that is being dissolved here is an impure copper, so as it dissolves, the impurities will go into the solution. It's just like when you bathe, all the dirty things in your body will go down, so the impurities in that impure copper will go down, and as it goes down, it will donate 2 electrons. Why? Because it's still at the anode. At anode, electron is being discharged, so it will donate 2 electrons and to form copper 2 ion into the solution. And that's why we can see it here, Cu, there is a loss of 2 electrons here. Now let's move to cathode. At the cathode, between copper 2 ion and hydrogen ion, which one will be preferentially discharged? So automatically is copper. Why? Because copper is lower than hydrogen in the activity series. So and that's why copper here, and also in terms of similarity, you can see that copper and copper sulfate, there is a kind of similarity in them, so it means copper is still what will be discharged at the cathode. And what will now begin to happen, there will be an increase in mass or size. As the impure copper dissolve from the anode, it will be building up the pure copper in cathode. So this is what I mean. It means on the left, as the copper is dissolving, let me just use this drawing, assuming this is where the impure copper is, as it's dissolving, entering into the electrolyte, the dissolved copper will now come to the right where we have pure copper, then it will be building this, making it bigger, but the impure will be going down, the pure will be getting bigger, just like a recycling. So you recycle something that is rust and then turn it to a new ion. So that is what happens to copper sulfate when we use copper impure and pure as our electrodes. Now let's still proceed to another specified electrolyte, and that's diluted sodium chloride. Here we'll be using platinum as our anode, also platinum as our cathode. So from here we have NaCl, that's brine. Another name for brine is NaCl, sodium chloride. Then we also have our water. So what is the anion here? Cl is an ion here, then OH is an ion here. While sodium will be the cation, hydrogen the cation here. So which one will be the preferential discharge at the anode? So it means between Cl and OH. OH will be preferentially discharged because it's lower in the activity series, just as I've shown earlier. And what normally happens at anode, there's always a loss of electrons, so this will give us OH, and the OH will duplicate to give us water and oxygen. The oxygen will duplicate to give us oxygen gas, meaning the oxygen gas is produced here. Then at the cathode, between Na and H, which one will be discharged? That's H, because H is lower than sodium in the electrochemical series. So meaning that the H, remember at the cathode there is a gain of electron, so the neutral hydrogen produced will duplicate to give us hydrogen gas. So meaning that this will also be discharged. And if oxygen and hydrogen are being discharged, it means there is loss of water. So meaning that the NaCl, the source that we call diluted, full of water, it will become concentrated as a result of loss of water. Now let's also consider concentrated sodium chloride. We have looked at diluted, but now concentrated, talking about brine again, brine solution. So here we'll be using carbon as our anode, platinum as our cathode. So from the NaCl and water, what is the anion? That's the Cl, the anion here OH, cation Na plus, cation H plus. So which one will be preferentially discharged here? Take note of this word concentration. Concentration is another term or factor that can determine preferential discharge, meaning that sodium is concentrated, chlorine is concentrated. So meaning from here at the anode, between Cl and OH, which one will be preferentially discharged? That will be Cl this time instead of OH. OH is for position, but now we are considering concentration. So meaning that Cl will be discharged because Cl is part of the concentrated, because it said concentrated NaCl. So Cl is concentrated, so it will be discharged. Take note, the apart from being concentrated, the distance is also close. That means the distance between Cl and OH. So that's why the condition we hold. Look at where Cl is and look at where OH is. So because they are very close, so the Cl will be discharged. So let's look at the other one. So the other one is okay, before that, remember anode, that's where electron is being lost. So mean that the Cl minus will turn to Cl and the duplicate will give us chlorine gas, meaning that this is one of the products of this electrolyte. And that's to remind you that if you are told to list the importance of all these things I'm doing, all the electrolysis, one, you can say electrolysis can help us to produce gas. As we can see, we produce Cl2 gas here. And apart from that, it can be used for purification. When we purified copper the other time, the impure turned to pure. Another one, we still have electroplating, where we'll be coating spoon. That means if we have spoon, so as maybe nickel, then we also have silver on the other side. So the silver will dissolve into the electrolyte and then come to the side of the spoon and begin to coat the spoon. That's electroplating. So meaning that one also is another importance of electrolysis. Now apart from that, electrolysis can still be used for producing compound, like chemical compound. So, and what is the compound? Like NaOH. So you will still see where we'll be producing NaOH. So with this, you can say GPEC. So G, P, E, C, they are the importance of electrolysis. That means to produce gas, for purification, for electroplating, and for producing compound. So let's proceed. So here now we have seen that gas Cl2 is produced. Then at the cathode, between Na and H, which one should be discharged? Here I said instead of Na plus. Remember that Na plus is concentrated. Normally the more concentrated one should be discharged, which is sodium, but no, it won't be discharged here. Why? Because hydrogen would rather be discharged due to wide distance. When I say wide distance, come and check here between hydrogen and the, so as you can see here, that's the distance we have between the hydrogen. So we have a very far distance or wide distance, so between the hydrogen and then the sodium. Sodium is at the topmost layer. So see where sodium is. So the sodium is at the top, but see where hydrogen is too far. So whenever there is a wide distance, we will not consider the concentration again. So just like using the idea of maybe in an organization, maybe like in a church, so whereby a rule has been laid down that anyone that does one thing or the other, so the person will be excommunicated. So maybe it's now the head that does that, so they may try to consider, so because of the wide difference or maybe the distance, so and that's why here now we have to pick hydrogen instead of sodium. So that's for wide distance. So here now hydrogen will be discharged, and take notes, as cathode, electron is always being gained. So when electron is gained, we have hydrogen, and which will be duplicated to form hydrogen gas. So meaning that hydrogen gas is also another thing that will be discharged here. So, and apart from that, when hydrogen gas is being discharged, if we look at all the things that have been discharged, so let's come back to where we stopped. So we said chlorine gas will be discharged, hydrogen gas will be discharged. So when these two things are discharged, so it shows that the solution becomes what? Alkaline. because H and Cl, that's an acid, HCl. So once HCl is discharged, then it will remain a base, alkaline. And what is that base? Remember, we are considering brine, sodium chloride, and what? And water, H2O. So from this H2O, we said H is being discharged, Cl is being discharged, so it will remain Na and OH. And what is NaOH? So that is a base. So mean that NaOH will be discharged. Now, there is another thing we can also consider when we come to this side. That's we want to move to number 6. So we have taken number 5, concentrated sodium chloride, using carbon and platinum as our electrode. This time we want to use carbon and mercury as our electrode. So when we use carbon and mercury, the first thing is that the anions still remains, cations remains, but when it comes to anode, that means between Cl minus and OH minus, which one will be discharged? Is still the same Cl minus. Why? Because it's concentrated, and also it's more, is closer. Now let's, and finally Cl2 gas will be produced, just as it happened here. But when we come to cathodes, that means between sodium and hydrogen, so which one will be preferentially discharged? So earlier, as when we were doing this one, when we use anode as carbon, cathode as platinum, remember we took hydrogen, we did not take sodium because of the distance. So normally sodium ought to be discharged because of the concentration, but we chose hydrogen because of the wide distance. But here there will be a change. So sodium is what will now be discharged here. Why? Because in this case we are looking at mercury. Anywhere you see mercury, mercury has affinity for sodium. So, and that's what we call nature. So because of this nature, sodium will be discharged here. And once sodium joins with mercury, it gives us what we call amalgam, sodium amalgam. So here we have sodium amalgam. That means the mercury that has affinity for sodium, to bring sodium to itself to form this amalgam. And water that is around also from that reaction will still join with this amalgam, and once it joins, NaOH will be produced. Hydrogen gas will also be produced, that means taking the Na and the OH here, it will remain H. So hydrogen gas will be produced, and the Hg that is here, mercury, will also be produced. So this is where we said in electrolysis we can use it to produce a compound. So this is a compound. So, and that's for number 6. So this time we'll be moving to electrochemical cell, but that one will be in the next video. So thanks for listening.